so what we're going to look at now are two different views of what is mathematics. What you will hear a lot of in the media, but also in schools and preschools, the term numeracy is being used significantly now in mathematics education. So what we want to do today is have a look at what the difference between these two concepts are. So what is mathematics? So before you start this module, I want you to sit down and write down what you actually think is mathematics. Just take a few jottings and work that through. When you've done that, then scroll through to the next part of this lecture. Just as a little footnote, what you might find useful in working your way through this lecture, it's structured a little bit differently. I've integrated a number of video clips that you might want to look at particular points in this lecture. So that will be your call. You can do that how you like, but they are linked to particular areas. So in terms of what have you thought about in terms of mathematics, I could pretty well hazard a guess as to what some of your responses will be. Some of them will be about the content that you've encountered, whether that's doing sums. Now, I use the word sums because I think that's what most people use, but really it's an incorrect term. To sum something means to add it up, but generally when people talk about sums, they're talking about algorithms, addition, subtraction, multiplication and division. So I'm using that term very loosely in this context. You might also be talking about counting or algebra or measurement or probability or graphs or something along those lines, but it's about the content of mathematics. Some of you might have also talked about some of the processes that we would have had, and many of that will be about the four operations: addition, subtraction, multiplication and division. Those sorts of operations. It may also be about things like problem solving, that sort of area as well. Others of you may have talked about emotions, such as, and some of you hopefully will have a lot of pleasant memories. Others of you may have more negative memories, but that will be quite an emotive area. So really, when you think about mathematics, there are these key components of mathematics. There's the content, the processes and the affect. So depending on your response, I'm sure you've drawn on some or all of those. However, as a teacher of mathematics, your task is now significantly different. So what your task is now is to create quality learning environments that are going to enable your students to succeed in all of those three areas in terms of the content, the processes, and come out of mathematics feeling good about themselves as learners. So generally, that's when we're talking mathematics. So what's this new term numeracy that you're going to hear a lot about? It's a term that's used in education by educators, policymakers, are talking about mathematics and numeracy. So it is important at this point you come to appreciate the difference between these two concepts, because they are foundational in how we teach mathematics in today's classrooms. Understanding the differences and the nuances of these two concepts is central to your work. If you ask people how good they are at mathematics, sadly maybe 80 to 90% of the population are quite happy to say, I wasn't very good at mathematics at school. And yet, you know, when in their everyday life, some of these people are very successful business people, entrepreneurs, all sorts of occupations. Yet, they can keep budgets, they can work out all sorts of things to do with mathematics. And yet, when you talk about mathematics, they generally relate it back to school and not how they use mathematics in the world beyond schools. What often happens is that people are more confident when they're using and applying mathematics in their everyday lives, but they're less confident when they have to use school-taught methods. And I'll give you a nice example here. If I said to you, calculate 5.00, take away 3.75, or 3.78 to make it even trickier, if you like. If you had to do that in your set-out algorithm where you have 5.00, and then you have to line up the ones, the tenths and hundredths underneath and do the subtraction. You may not be that confident with it, but if I said that you bought an item in the shop for $3.78 and you had $5, how much change you would get, most people would come up pretty quickly with $1.22. And yet these are the same. It's the same mathematics that's being used, but the context shapes not only the processes that people will use to solve that problem, but also their confidence with the method they've used. What is now important in mathematics is that numeracy is every teacher's business. Whether you're an early childhood teacher, a primary or a secondary school teacher, every teacher is now charged with the teaching of numeracy. So what I'd like you to do is there's a YouTube clip. It's a TED talk, and this gentleman's talking about the 3 areas of core skills that we need: literacy, numeracy and graphacy. Now, we talk a lot about in schools about literacy and numeracy, and I'm no doubt you're coming across this in your course, but increasingly now we live in a data-drenched society, and graphacy is as important as the other 2. So this is just to extend this notion of numeracy as well. Much of the graphacy, I have to say, is related to numeracy, but it would be very interesting if you can watch that video. So what is numeracy? There's a lot of debate about what is numeracy, and these are some of the views that you will hear, and I've heard them all myself. That numeracy is the same as mathematics. It's just a new name for mathematics. That's all it is. Other people will say that numeracy is about the study of number. Others will say it's a very subjective position about you can say this and I can say that. Others will say numeracy is about applying mathematics to everyday concepts. Some people work in a deficit model and say that numeracy is just a lower level of mathematics. It's the mathematics for those who can't do real mathematics. They can do the numeracy classes. Similarly, numeracy is offered to those students who can't do real mathematics. Other views are numeracy is everywhere. Everywhere in life is what is numeracy, and maths is the stuff that we do at school. Similarly, numeracy is the easy stuff and mathematics is the hard stuff, as if mathematics takes a higher rung in the hierarchies of learning. However, some of these views have some validity and others don't. Hopefully, you'll start to get a firm view about what is numeracy. So one view of numeracy is that it is everywhere. This view shows that what is learned at school is only one form of mathematics, and that in our daily lives we are surrounded by mathematics. Mathematics is everywhere. So what's mathematics and what is numeracy? This is a start in terms of moving away from the high status that's afforded to mathematics, where only very clever people can do mathematics in inverted commas, to something that is more encompassing. What we do know is that many people will use mathematics in school, but they don't use it to apply it into the worlds beyond school. So a more encompassing view, and this is the view that is the one you'll see a lot more in schools and the ones that are being pushed by policymakers, that a more encompassing view of mathematics relates to not only content and processes, but it's the capacity and the confidence and having a disposition to use mathematics as a tool to solve many aspects of daily life. So if you're doing budgeting, or if you're going to buy a car, or if you're going to use some sort of mathematics, it's having the confidence in the mathematics and the tools of mathematics to solve the problems that you need to use. So you need mathematics as a tool to actually solve many aspects of your daily life. But it's about having the confidence to use mathematics. As we've discussed in other lectures to date, too many of our students exit from school not confident with mathematics, scared of mathematics, unable to do mathematics, have a belief that they can't do mathematics. So when they come to problems in their everyday life, they're reluctant to use mathematics as a tool to help them solve those problems. Numeracy is the capacity and willingness to apply mathematics to solve those problems. It's much more empowering. So why is there this shift to numeracy as opposed to mathematics? Well, what we need in schools is students to be confident in selecting and using the appropriate mathematics to solve everyday problems, rather than relying on intuition or gut feeling or somebody else to use mathematics for them. We also know that there's very little transfer between what is learnt at school and what people do in their lives beyond school. Until fairly recently, if you wanted to decide which was the best bottle of Coca-Cola to buy, would it be a 2-litre one or a 1.25-litre one, you needed to use proportional reasoning. And what we found most people would do was not use proportional reasoning. They often bought incorrectly. And that's been very recognised. So what we do have now in the supermarkets is you'll see on the tag how much an item would cost in terms of average 100 mils or 100 grams or whatever the unit of measure is. So that that overcomes people's lack of confidence to use proportional reasoning. What we also know is that school mathematics is very, very esoteric. That means it's very applied to a particular way of doing. So what we do need are ways to apply this very powerful knowledge that we have in mathematics into the lives of real people and real world contexts. So we want mathematics now to be a powerful tool for enabling good decision making, rather than just ticks on a piece of paper. By focusing on numeracy and having problems that need mathematics to be used to solve the problem, people now can see the link between what they've done in school mathematics and what they need in their real lives beyond school. Mathematics can be applied to so many contexts. It's often called an enabling science. That means it enables people to solve real problems. So being able to use mathematics across many contexts, across many problems, across many situations, it becomes very empowering, rather than what we have known is very disempowering. So what we do know now in terms of what your work will be as a teacher is that you need to focus much more on numeracy, which does mean that students still need to have their basic mathematical ideas, but they need to be able to apply those mathematical ideas to real problems in order to solve them, so that people can see the links between mathematics as a transdisciplinary knowledge. So what we do know is that mathematics and numeracy is found in all of our curriculum areas. And numeracy across the curriculum now is a very heavy emphasis, and what you will hear in schools is that numeracy is everybody's business. So what is good numeracy? Good numeracy is a very empowering form of mathematics. As we discussed in the very first module, being able to use mathematics in a way that is empowering and can be applied, and understand the mathematics that you're using, is central to being a good maths learner, and in the case of a teacher, a good maths teacher. So mathematics can be very empowering when people understand and can reason mathematically and communicate mathematically. So having the mathematical concepts is part of mathematics. Being able to apply those mathematical concepts in constructive and informative ways is what's being as numerate. So people, students, learners, adults, can see the value of mathematics as an enabling tool that helps them solve their real day tasks. Good numeracy engages learners, because unlike the screeds of exercises that you did off the board or the worksheet or the textbook, what we're looking for now are problems that will engage our learners. So the problem becomes engaging, and the capacity to use mathematics becomes a real construct for the learner. It's certainly far less threatening, because it's not right or wrong now, because your solution will help you, guide you towards the mathematics that you need. So it helps learners to see why they need to know, why they need to know and understand, and use mathematical concepts to solving problems. So now mathematics has a purpose other than sitting and doing mountains of problems, tasks, equations, which was part of that behaviourist thinking. Having strong mathematical understandings is critical and absolutely foundational to being predisposed to use and select and apply those mathematical concepts. So students need to develop two things in parallel. They need to develop their mathematical understandings in terms of processes and concepts, at the same time being able to apply these knowledges and dispositions to everyday situations. So our goal as a good numeracy teacher is to teach mathematical concepts and processes in ways that are engaging and can be applied for our learners.